In this video, I'd like to show you a couple problems where you're asked to determine the gram amount of precipitate that would dissolve in the presence of a common ion. These problems are essentially an extension of the common ion effect, types of problems you've done before. In this instance, what gram amount of silver chloride will dissolve in 1 liter of 0.1 molar sodium chloride? We set up the ice table as we would in a common ion effect problem. And we assume the amount of chloride produced from the ionization of the silver chloride is negligible compared to the amount of chloride present in the solution. Solving for x, which represents the concentration of silver, we get 1.77 times 10 to the minus 9th. So in 1 liter, there are 1.77 times 10 to the minus 9th moles of silver ion. So keeping in mind that there's a 1-to-1 ratio between the silver ion and the chloride ion, 1.77 times 10 to the minus 9th is the number of moles of precipitate. Therefore, using the molar mass of silver chloride, we could determine the gram amount that dissolved. In this problem, we're asked to determine the gram amount of silver carbonate formed in 1 liter of 0.05 molar sodium carbonate. The KSP for silver carbonate is 8.46 times 10 to the minus 12. We set up an ice table like we did before. We write the equilibrium constant expression with silver concentration squared times the carbonate ion concentration. And we're going to assume that the equilibrium concentration of the carbonate is 0.05. We solve for x because x is the molar solubility of the compound. After substituting in the values, x is 6.5 times 10 to the minus 6 moles per liter. In 1 liter, there is 6.5 times 10 to the minus 6 moles of silver carbonate. So the grams of silver carbonate that dissolved is the 6.5 times 10 to the minus 6 moles converted to grams, which is 1.8 times 10 to the minus 3 grams of dissolved precipitate.